Okay, when we've got an expression, an equation expressed in turning point form, it'll look something like this. We've got a, then we've got x minus h plus k. Now, your value for a controls the dilation and also reflection. This value of h and this value of k control translation. So once again, if it's negative, then it moves to the right. If it's positive, it'll move to the left. Your positive k moves it up, negative k moves it down. And as a result of all this here, we have a change in our turning point to a value of h and k. Now, let's put that into practice. We've got negative x minus 1 all squared minus 1. So basically what we'll be asked to do is first find coordinates of the turning point. So over here we've got negative 1 minus 1. So our turning point will be at 1 and negative 1. Remember, if this is negative, our value here is positive. If this is negative, our value here is negative. Okay, so that's what we end up with there. Now, okay, so we've managed to identify coordinates for a turning point, being at 1 and 81. From there, we'll also be asked to state whether it has a maximum or a minimum turning point. Now, like we said, this value of a controls the reflection. So, because this is negative, we know that our graph is going to turn this way. Because of that, we say that it has a maximum turning point. So, every other value will be lower than that. So, we've got a maximum turning point. The other thing we'll be asked to do is decide whether it is wider, narrower, or the same as x squared. So given that we've got, given that our value of a here is actually 1, we don't see anything, we don't generally write the number 1. Given that it's 1, then we say it's the same width as y equals x squared. Okay, so just to recap. Turning point form, the A controls dilation and reflection. If it's positive, it stays as a smiley. If it's negative, it becomes a frowny. Dilation is the number, so if it's greater than 1, it becomes narrower. If it's less than 1, it becomes wider. This negative tells the graph to go to the right. If it's positive, it tells the graph to go to the left. This tells us how far. This value of k, if it's positive, we go up. If it's negative, it moves it down. As a result, h and k provide coordinates to the turning point. Looking over here, if it's negative, it becomes positive, negative stays negative, and these provide our values for our coordinates to the turning point. Because it's a negative function, it's a maximum, and our number here, because we don't have a number, we take it as being 1, so it's the same width as y equals x squared.